Hi guys. Okay, so this is the domain and range part 1, 2, 3 in our playlist. Okay, so we're talking about domain and range. Now remember, domain means our x values. And it can also mean our input. Range is another word for our y values or the output of a function. Okay. There's lots and lots of words that mean domain and range. And one way to remember all of those words is using this little acronym here. Okay, so we're going to say doctor, XY, lost his ID in Ohio. Okay, so D stands for the domain, and domain means our X values, and it also means our input. Okay, another word you're going to hear later next week is our independent variable. So that's the other I you see. Everything in this first column all mean the same thing. They all mean domain, X values, independent, input. They all just mean X or domain. Okay, everything in this second column mean the same thing also. So R stands for the range. Range is also our Y values. Later next week, you'll hear the words dependent variable, and it can also mean our output. Okay, so same column, same meaning. Dr. XY lost his ID in Ohio, and you can see my wonderful driver's license of Thor in Ohio up on a green poster on the wall in the classroom. That is up there all year, and this is there to help you remember through tests and everything. All right, so domains. If we have a relation or a function and it's a list of ordered pairs, let me get that off the screen. What happened? Okay. It's a list of ordered pairs. So we have our x's and our y's. So we're looking at all the states of domain and range. So to find the domain, we're going to find all the x's. So that is the first number in my parentheses in each ordered pair. And to write a domain as a set, we use curly brackets, like it said in our mathematics video earlier last week. And we're just going to list all of those x values with a comma in between them. So I have 2, 4, 3, 6, and 2, but 2 is already there. We don't want to list it twice. Once it's in the set, it stays in the set. Okay, and then that's the last one. I'm going to close my curly bracket. Okay, my range is the y values. So looking at the y, I'm looking at the second number in each set of parentheses or in each ordered pair. So range is a set. I'm going to make curly brackets to show that it's a set, and I'm going to list all those y values. I've got -3, 6, -1. 6 is a repeat, so don't mark it twice. Remember, I'm a lazy mathematician and I don't want to write another number more than I have to. And then there's a 3. And close your set. Now, is the relation a function? Well, remember we said in the domain we had a repeat of the 2 that we didn't want to write twice. So that right there tells me that no, it's not a function. Okay. Number 2, stating the domain and the range. Domain means x, domain and x. So I'm looking at the x's, or the first numbers in my ordered pairs, and list them: -3, -2, -1, 0, 1, and +2. Okay, so if it's negative and positive, those are two different numbers. Make sure you list them both. Range means the y, and our y is the second numbers here. Now, if you haven't noticed already, something looks fishy there. Hello, Daisy. So we make our set with curly brackets. That's a 5. Oh, but that's 5, and that's 5, and that's 5, and they're all 5s. I don't want to write 5 that many times. I'm going to write 5 one time, and that's my set. It's okay to have one number in the set. So is this a relation? Is the relation a function? Well, did any of those domain values repeat? No. So yes, this is a function. All right, number 3 is a mapping. Remember, our set on the left is always the x, or the input. So that's our domain. Mappings are very easy. You can see all the numbers right there. So we're just going to write everything in that set. And our range is always the y's, or the output, which is the set on the right. So I'm going to list those in curly brackets, all the numbers I see on that right-hand side. Now, we've been talking about the mappings, and we've been saying that if each input has one output, then it is a function. And if I look at this, each input has exactly one output, but we also have to have an input for each output. So you see here, we have a 3 that has nothing mapped to it. We have an extra output, and this makes it not a function. So there's one extra little stipulation there. Okay, number 4. Domain is my x's. So I'm going to list everything that I see on the left-hand set. 0, 1, 2, 7, and 9. My range, I'm going to list everything I see on the right-hand set, because that's the y. So I have 4, 5, and 9. So is it a function? We're looking at each input. Each input only has one arrow. Okay, and every output has something connected to it. So yes, it is a function. All right, and our last mapping. Domain is the x's, everything on the left-hand side, 3, 5, 6, and 7. Range is all the y's for everything on the right-hand side. Curly brackets, 4, 5, and 9. Is it a function? Got 3 with one arrow, 5 with 2 arrows, 6 with one arrow, 7 with one arrow. Okay, so this 5 with 2 arrows throws me off. So this is no, it's not a function. All right, tables also have a domain and range, and tables are just as easy as mappings because it's already labeled for you. X means domain, so we're just going to list all these numbers in the X column, but we're going to do it in brackets, and we're going to separate them with commas. So -7, 4, -2, 8, 10, and 19. And my range, remember range meant Y. It's already labeled for you, and we're just going to list everything in that Y column. 12, 9. Just remember, if you come across a repeating number, we only want to do it one time. -11, 17, 6, and -5. Nothing repeated there, so I just listed them all. All right, so far, easy. All right, so here's the challenging part. Go ahead and flip your paper. Okay, so far we've talked about the ordered pairs, and we've talked about mappings and a table. All of those are discrete functions or relations. So we're going to say a set of ordered pairs are mappings and tables. And sometimes we see graphs with points only. Okay, I haven't put anything on this to show you that, but you will see some later this week. Okay, so discrete is anything with a set of points. Okay, so all of these are just sets of points. What makes it continuous is like these graphs up here. We don't just have points, we have lines that connect a bunch of points. So a continuous graph is a graph with a line. Okay, so a graph with a line, 7 and 8 are continuous graphs. Okay, and when we have continuous graphs, we can find domain and range, but we're using compound inequalities to write their domain and range. Okay, so if we write in the domain, we're going to look for our minimum value. And remember, in compound inequalities, we always have less than or equals to. Domain is the x value, so an x will be in the middle of our symbols. Remember, those can be less than or equal to. And it's going to be our maximum value on the outside. So we're going from minimum to maximum. And if we're talking about domain, if we're talking about minimum value, domain is the x-axis because it's x's, right? So we're looking at the x-axis, and minimum, it gets smaller on the left-hand side. So domain, the minimum is going to be on the left side of the graph. And if we look at the maximum, the right side of the graph is bigger. So we want to see how far right does the graph go. So I'm just kind of sandwiching my graph right here. So this is as far left as it went. And then this is as far right it went. Okay, so looking at the x values here, this was at 0. So my domain is 0. And that hit at the line. If it's at the line or if it's on a closed dot, I need to make that an less than or equal to. This is domain, so I'm going to use x. And then as far right it went, the maximum value, it's at the 4 on the x-axis. And looking at that 4 on the graph, those are both open circles. Open circle means less than, no equal. Okay, when we write our compound inequality for the range, we also want our minimum value, a less than or equal to. But remember, range is a y, not an x, but a y. And then surrounded by either a less than or equal to our maximum value. Okay, so again, I'm going to look at my graph. Remember, range is y. So looking at the y-axis, my minimum, it's smaller down at the bottom of the graph. So your minimum value is how low can you go? And on my maximum value, it gets bigger on the top part of the y-axis. So it's going to be how high it goes. Okay, so my graph, I'm just going to box it in again. This is where the graph went low. This is where the graph went high. Okay, so my minimum value, looking on the y-axis, this is -3. And it hits the graph at that open circle, so it's a less than. Range means y. And then it went up to here at an open circle, so it's less than. And hitting the y-axis, it's at a 1. So there's my compound inequality for domain and range. Okay. So added bonus question, is this a function? All right, number 8. Domain, I'm looking for my peak pen. How far left did it go is my minimum. So here's as far as it went to the left at that point. And then maximum value, how far did it go to the right? Right here. So here's my second. Okay, so my minimum value here is at -1 on the x-axis. And it's a closed dot, so I'm going to make that less than or equal to. Domain is x. And then my maximum value hits the graph here at an open circle, so it's less than. And on the x-axis, that is a 4. Range is the y. Minimum value is how low did it go. So I'm going to box in my graph here. And maximum value is how high did it go. Okay, so my low, my maximum, how low, right here on an open circle on the y-axis, it hits a 5, -5. On the bottom means negative, right? Open circle means less than. Range means it's a y. And then how high did it go? Way up here with a closed dot. So I have a less than or equal to. And over on the y-axis, it says it's a 5. Okay, so my range is from -5 to +5. All right. Okay, we're going to talk some more about these kinds of domain and range in class tomorrow. So I hope you get some practice in writing those compound inequalities. I'll have a good night.